We've had a discussion already about using Wireshark to capture and analyze network traffic. Let's make the rubber hit the road here and let's actually do it. So on my screen, I've navigated to the wireshark.org website because Wireshark is a free tool. We don't have to sign in, we don't have to pay for it, or anything like that. And from here, I could click the download link and I could select the platform that I want to run Wireshark on, whether it's Windows, whether it's the Mac OS, or whether I want the source code to compile it for my distribution of Linux, whatever the case might be. I've already downloaded and installed Wireshark, and so what that means is that when I go to my start menu and type in Wire, for example, I'll be able to select the Wireshark app. So I'm going to go ahead and run that. Now remember, you're only going to see the network traffic that you should see based on how you're connected to the network. So what that means is if you're plugged into a regular network switch that hasn't been configured specially, you don't see anybody else's traffic. So you might want to talk to your switch admin and get them to configure your switch port so that it can see all of the traffic on the switch. So you get a real picture of what's happening when you capture and analyze traffic. So here in my Wireshark installation, in the bottom half of the screen, I have a number of network interfaces that I can capture traffic from. So if you have virtualization software installed like I do, you might have things like VMware network adapters. You might have standard wired connections, Ethernet connections, let's say. You might have Wi-Fi. You might have a Bluetooth adapter. A Bluetooth adapter is just another type of network card. And if you have a Bluetooth adapter, you probably do in your smartphone. Every smartphone supports Bluetooth. Well, then you can actually capture Bluetooth traffic and analyze it. So at any rate, what I'm going to do here is I'm going to choose my Wi-Fi network adapter. Now I have a little line graph that's showing me that there is some traffic, there is activity on that interface. To start a capture there, I just double click right on it. Okay, well that's pretty easy. I can see all kinds of traffic happening here. But what I'm going to do is generate some specific traffic such as pinging. So for that, I'm going to open a command prompt. And just for fun, what I'm going to do is I'm going to run ping www.totalsem.com. Now I see that DNS name resolution is working. I've got the IP address, but all my requests are being timed out. And that makes sense because ICMP traffic, which is really what ping uses as the underlying protocol, is blocked. But nonetheless, let's go back into our Wireshark capture session. And I'm going to stop it. So I can click the red stop button up at the top, so I'm no longer capturing traffic live. Now, if I select one of these captured packets, so let's say a TCP packet selected randomly, we've got the source and destination IP, it's a TCP packet, and I've got a few details over on the right, like the length of it and so on. But down below, I actually have the packet headers, so essentially only the addressing information. For example, the Ethernet 2 header, some people call that the hardware header, that's where I've got the source and destination MAC addresses. Those are the 48-bit hex addresses that identify a network interface. After that, we've got the Internet Protocol or the IP header, in this case for IPv4. Things like the time to live are here, the following protocol, which is TCP, the next higher level protocol according to the OSI model. And I've got the source and destination IP. The next header is the TCP header. Now this one's interesting because TCP deals with things like port numbers, whereas the IP header deals with, you guessed it, IP addresses. So here I've got a source port of 443, and I've got a destination port that's a much higher value. What is this telling me? It's not enough to be able to capture traffic. You need to be able to look at it and make sense of it to a degree. So I know that HTTPS web servers listen on TCP port 443. So there's an HTTPS web server involved here, presumably, unless it's a forged packet. So if the source is port 443, that feels like it's traffic coming from a web server back to a host. A response, in other words. Sure, that's the kind of deductions that we can come up with by looking at the traffic and thinking very carefully about known port numbers and what direction the traffic goes in. Now, the other thing that's interesting is we can learn a lot about how secure or insecure our network is with a network traffic scan. Now, for that, I'm going to open up a previously captured network packet capture file that I have. So I'm going to go to File, Open, because we can choose Save, right? We can save packet captures and analyze them later. One of my habits is that when I travel and I'm in an airport terminal or at a resort or at a hotel or what have you, I'm just in the habit of capturing traffic all the time. I don't know why. Call it an addiction. Is that illegal? Not at all. What you do about it might be, if you find vulnerabilities and exploit them, obviously you could be crossing the line, but packet capturing, no problem. So I've got collections of hundreds and hundreds of packet captures from airports all around the world and so on that I still have yet to analyze just for fun. Yes, that's what I do for fun, sometimes. But anyway, File Open. I'm going to open an existing scan. And this one, let's say, is going to be one that I know has clear text authentication over HTTP. So a very poorly designed web application. So I'm going to continue without saving. I don't want to save what I've captured. I want to open up my capture. Okay, so what am I looking at here? Well, I don't know, TCP traffic, SSH. So I could go down and look at each individual packet by itself. But what I could also do is I could also filter. We talked about capture filters, or what I'm going to do here, I can apply a display filter. For instance, I want to see HTTP traffic. Well, type in HTTP and hit enter. You are now looking at HTTP traffic only. So you can get much more complex with filters. You can filter by IP address, port, the direction of the traffic, and so on. But in this case, it's only HTTP. What I could then do is filter it a bit further, or really search through it. What I could do is say, well, I wonder, is there any traffic that has the text password? This is possible. So if I go to the Edit menu, I could choose Find Packet. I'm looking in the packet details. I'm looking for a string. Let's see if we can see the word password. And when we go to Find, it looks like we're already there. There's already a login, it looks like, to a web application, a page. And as I scroll down further, I can read more details. I can also do this. I can select a packet that might have been involved in that longer conversation. You can imagine when you sign into a web application, it's not one packet. It's a collection of packets that use the TCP transport. So what I can do is, positioning myself somewhere within that conversation, I can go to the Analyze menu and choose Follow TCP Stream. And then it kind of puts it all together for me, instead of me having to go through individual packets, where I can say, oh boy, I think I know what's happening here. I think the username is admin and the password is password, because that's what it shows me. Now that's a clear violation of network security. This is a poorly designed web app that is only using HTTP, not HTTPS. So the communication is not encrypted, so no wonder it's so easy for us to find these credentials. And of course, we're probably all thinking, well, good thing nobody does that anymore. It's still in use all over the place, believe it or not. Now, the vast majority of public-facing web servers that are owned by larger companies, of course, secure the connection, but you'd be surprised at how often you do run into this. You just have to position yourself somewhere where you can actually capture that type of network traffic. Now, we could go on and on with how to use Wireshark to analyze traffic and filter it. There's so much more you can do. And if you find this interesting, go on out and search for other training materials related to Wireshark. But for the Security Plus exam, we just need to know what the tool can do and have a general sense of how to interpret what we see after we've captured network traffic.